All right, we're going to look at rates of change in polynomial functions today. So we've already done this ARC, IRC, and I'm just going to refresh it. So a reminder that average rate of change is really just the slope of a secant line, and instantaneous rate of change is just the slope of a tangent line. So ARCs are over a larger interval. That's sort of an arbitrary definition, and instantaneous is over a very, very small interval bordering on zero or trying to get close to zero. So quick refresher, find the average rate of change from x equals 2 to x equals 6 for the function f of x. And it's a cubic in this case, and that's what's different from when we originally did this, as we now have some higher powers. So we're just going to see how cubics and quartics behave in this particular situation. So you remember that our ARC is just a slope formula. So let's grab our pen up here and let's do a little bit of writing. So our ARC is going to be f of 6 minus f of 3 all over 6 minus 3. And then off to the side we might take f of 6. That means take a 6, put it into the f function, minus 4x plus 5. And I better grab my calculator just to be on the safe side here. Hopefully my calculator works. So 6 cubed, 216 times 3 minus, oops, I didn't put a 6 in here. Let's jump over here for a second. I've missed my 6. So we'll put a 6 in here. It's 24, so we have what, 648 minus 24 plus 5, and by all means check my math. My calculator's batteries are a little bit low, so just making excuses, you know, that type of thing. 629. Okay, and then f of 3, oh sorry, 2, f of 2. We do the same thing, you substitute a 2 in for all of the x's and come up with the total. So 2, 4, 8, 24 minus 8 plus 5, so 24, 16, back to 21. And then we come up to our ARC, and this is our actual question. 629 minus 21 over 6 minus 3. So we have 608, if I did that right, divided by 3. So we have 200 and something, 608 divided by 3. So there's 202 full units and 1/3 left over. 2/3 left over. And you can use a decimal as well. So there's your ARC quickly reviewed. Just double check my numbers here. But the process is just put in the function values. Just remember the f's are not variables. It's a functional notation, so you're substituting x or 6 into the original function. Now if we do an IRC, it's very much the same process, but you'll notice instead of giving an interval, you're just given one value. So we choose another value that's really close to it. So our formula for IRC was our difference quotient. And you remember the h was really, really small. So we do the same thing. So pick a value that's really close to x equals 2. So we might say x equals 2.1, 2.01, whatever you like. So your IRC is simply going to be f of 2.1 minus f of 2 all over 2.1 minus 2. And this bottom piece, when you subtract them, that's where the h comes from. So in this case, h is 0.1. So they just write h on the bottom, but it's just the subtraction of those two. So if we put 2.1 into our function, 3 times 2.1 minus, 2.1 cubed. It's a cube, sorry, minus 4 times 2.1 and plus 5. Definitely have to calculate that one. 2.1 y to the x 3 times 3 minus 4 times 2.1 equals plus 5. 24 0.383, and it's always a good idea to keep a couple decimal places until your final answer, just to see how things pan out. So again, 3 times 2 cubed minus 4 times 2 plus 5. So 2, 4, 8, 24 minus 8 plus 5. So 16, 21. And then we just come back here and we have 24.383 minus 21. And again, if I make a math mistake, my apologies. I'm kind of doing this late at night, but that's okay. We'll give it a whirl. Minus 21 divided by 0.1, and I get 33.83. So again, we're really focusing on the process. So if I have a boo-boo, don't sweat it. The process is, though, we need two values that are really close to each other. What you should always have too when you do this is there's these two values here and here. If your points are really close together, your x values are really close together, like 2 and 2.1, you would expect your y values, and that's what these are. These are y values over here, just as a refresher. So these are really just y values. You would expect the y values to be close together too, because they're close to each other. So always do that as a check. If you have extreme difference between them, then that's a bit of a problem. All right, so let's go back to this one. Now, we haven't seen this for a while, and it gets a bit messier when we have third and fourth order problems, but what if we want to find the general equation for the slope of the tangent? So this is the where we're going to substitute in, and you'll notice I have two versions here, either the a plus h, which is the textbook version, or x plus h. It's the same thing. It's just some x value plus a small difference of h. Whether you call it a or x, it doesn't really matter. I might do this one with x just for variety. So our IRC, when we set this up, this is going to get a little bit of big. There's a bit of algebra to make this happen. So our IRC, and it's mostly because of these guys right here, the cubed and the squared. So I like square brackets. So I'm going to put x plus h all cubed, x plus h all squared, plus 5x plus h minus 8, all in one bracket. And I'm going to just drag that whole thing down since I ran out of room. And then I'm going to say minus, and this is where if you do this with x's versus a's, the x's, it's just rewrite the function. X cubed plus x squared plus 5x minus 8, and all of that will be over h. Now this one here is going to be a bit of a beast to multiply out. The red flag or the target here is eventually you're going to end up with terms that all have h's, and if you remember the first time we did it, all of these terms on the right, all of these guys over here, they're going to cancel off with all of the terms, some of the terms on the left. So they should disappear and we should be left with just terms that have h's in them, which will eventually cancel on the denominator. So pause it if you need to, take a second. I'm just going to pause it here while I write out some of the algebra, just so you don't have to watch me do an algebra, which is kind of boring. Okay, so I've done two brackets first to start with here. You can see I've added some lines here. These two right here also gives me the answer to this. So if you're paying attention, you already have the solution now for x plus h all squared. That's this piece right here. And just a reminder, if you multiply a 3 term by a 2 term, you should end up with 6 terms, just as a check. And there's some bookkeeping things you can do to keep track of that. So I'm going to do that next, but I just wanted to point out that we actually have this piece already figured out. And so I'm going to pause it here, or pause it my writing here, and just fill in the next part. Okay, so I've done the next piece, and you'll notice 3 terms times 2 terms. I've used my bookkeeping here to just bump one line down. You can see there are 6 terms here, and by bumping down I can also see where my like terms are, because they're all arranged in nice little columns. If you're familiar with Pascal's triangle, that's also another option you could play with here, but we'll leave that for another day. Okay, so there is the first x plus h all cubed. We also have this already found here for the squared, and then it's kind of sloppy writing, so my apologies. This is 5 times x plus h. I don't know what happened to that bracket, but it looks really terrible. So let's just fix that right now. X plus h all squared. Okay, so let's substitute those pieces of information in. We'll extend this a little bit further. Try and keep everything on the screen. So your IRC, the first cube here is going to be all this stuff on the right. So we're going to have x cubed plus 3x squared h plus 3xh squared. You can see how the details of keeping track of the exponents is super important. Plus, now x plus h all squared, we already have here in the highlighted yellow, so I'm going to write that out. X squared plus 2xh plus h squared. Oh, yeah, that's a lot of terms. Plus 5x plus 5h minus 8. There's the first bracket right here. Okay, now I'm going to go minus. The second bracket is just the function. X cubed plus x squared plus 5x. All of that, and all of that is going to be divided by h. Okay, so now we play the canceling game, and we try and eliminate some things. So we'll move this up and see what we can find that's the same, what we can combine. We're going to start with canceling. So this x cubed cancels this x cubed. There should be an x squared in here. There it is. That cancels this x squared. There should be a 5x. There it is. That cancels out. And there should be a minus 8, minus 8. So that's one of the things we expect to happen. We expect the last function, just the basic f of x function, to go away. Okay, so now I'm going to go through and just write over what's left. So we have 3x squared h plus 3x h squared plus h cubed. Going to the next part, plus 2xh plus h squared, and it looks like plus 5h. Okay, and all of that is over h, so we check every single term has an h, which is awesome. That's what we wanted, because then we can factor out an h and cancel the h off the bottom. So you will factor the top h and then cancel. Okay, and I'm not going to factor that out and rewrite it again just for the interest of space. Okay, so my IRC now turns into 3x squared h plus 3xh plus h squared plus 2x plus h plus 5. Now if I do a quick check, are there any like terms? I don't see any like terms. And then that right there is the general expression. So you just choose your x value, like x equals 2, and you could choose your h value at 0.1, 0.01, whatever you like. But the nice thing about doing this method is you can actually set h to 0. Once you get that divisor of h out of there, you can set h to 0, and something really beautiful happens. If h is 0, which is the smallest amount you could set it to, that goes away, that goes away, that goes away, and that goes away. Nope, I missed something. Hold on a minute. I'm just doing my quick calculus check here. I clearly missed this dude right here. This h isn't supposed to be there. See, and that's why it's helpful to have multiple techniques under your belt. That h should have canceled. And so I was looking for a certain answer because I have some calculus skills. So now this guy goes away, this guy goes away, and this guy goes away. That makes more sense. So we have 3x squared plus 2x plus 5. And if I just go a quick check up here, my original function, 3x, 2x plus 5. Yep, that looks like it's the right answer. So this is my general equation for an IRC. If I choose an x value, an x value, whatever you like, x equals 2, plug it in. That will tell you the slope of the tangent at x equals 2. Boom, done. Okay, and some other neat properties. You'll notice this guy is a degree 2. What did we start with? We started with a degree 3. So every time you find the IRC, it should drop by 1 degree or 1 power. And what we'll find in the future is you can actually find the IRC of an IRC. So I could find the IRC using this expression, and we could keep going. And we would find that the next IRC goes down to a first degree. Okay, starting a little long here, so let's I'll leave this for you for a minute to try, and then I'll put the answers up here. So pause the video here. Yes, that's a fourth, but I got rid of all the other ones, so this is a fourth. So part of the expansion here is part of the challenge. It'll take some time, so pause the video, and then I'll put the answers up. Okay, so hopefully you've had a chance to try it. And I have written it out here, this x plus h to the fourth, that's for that bracket. So I did the first two together, the second two together, and created two trinomials. Now if you multiply a trinomial times a trinomial, that's a 3-term by a 3-term, you should get 9 terms. And this is where that bookkeeping skill or technique really comes in handy. So when I multiply out the first x squared into the next bracket, there's the 3 terms. I multiply the 2xh, which is the second term, into the second bracket, there's the 3 terms. I multiply the h squared into the second bracket, there's the 3 terms. So I can clearly see I have 9 terms. And a couple other aspects of the bookkeeping element for this, you'll notice that I'm getting like terms all lining up. So that's another way to keep track of your algebra. These are the little details that make you get answers correct, is when you take the time to write it this way. You notice the second term in, it's x cubes and h's. Everything lines up really nicely. If you know Pascal's triangle, or if you've heard of Pascal's triangle, that's another cool way to keep track of things. And what you should see here, if you're really paying close attention, and I'll bring your attention to it if you can't see it, is look at this. Fourth, third, 2, 1, none. So when you look at x's, they go down 4, 3, 2, 1, none. And then if you flip that and you look at the h's, 4, 3, 2, 1, none. And then lastly, and this is kind of a neat little trick, what's the total here? The total's 4. What's the total here? 4. 4. Oops, that was supposed to be a 4. Not sure why the highlighter did that. The total here of exponents, 4. Yeah, you get the idea. And then 4 on the last thing. It keeps drawing straight lines, not sure why. So these are little techniques that will help you get the right answer by checking the algebra. So all of that work was just to get the first piece. So let's ditch the shade here and let's start putting some things in. So now our IRC, get back to my pen tool. Okay, so our IRC is going to be square bracket. Again, I really like square brackets. It makes it easy to see. Is x plus h to the fourth plus 3x plus h minus 2. Okay, and then this one is just going to be the function. And this is why I like that f of x versus the a value. It's just easy to rewrite the function. And again, I'm expecting this whole thing on the right-hand side to cancel. So I'm going to move over a little bit. I'm off my screen. So let's put in the first one. So x to the fourth. Man, that's bad writing. Sorry. X cubed h plus 6x squared h squared plus 4x h cubed plus h to the fourth plus 3x plus 3h minus 2. That's the end of the first bracket. Minus the second bracket. Of course, you have more space on your paper, so you can do this across the page. This is a 4. These are both 4s. All over h. And now, what are we expecting to happen? Shout it out if you know. Things should cancel. That's right. Everything in this second bracket should cancel. So there's an x to the fourth, even though it looks like a 9. It's a fourth. There's a 3x. There's a 3x. There's a negative 2. There's a negative 2. So everything canceled as expected. If we go through now, we have 4x cubed h plus 6x squared h squared plus 4x h cubed. And again, I'm checking exponents as I go here. I'm looking for h's. And I look for like terms. I don't see any. All of this is over h. But every single term has an h. That's good. So I'm going to factor and cancel. And so I end up with a new expression of 4x cubed, 6x squared h plus 4xh plus h cubed plus 3. My denominator's gone, and I can set my h to whatever value I want, but I'm going to set it to 0 because that just makes my life way easier. So I have 4x cubed plus this goes to 0, this goes to 0, this goes to 0. Isn't that pretty? And then you're left with 4x cubed plus 3 is your IRC, and that is the equation for the slope of the tangent at any point on that curve. Okay, and for people who are learning or know calculus, you can always go back and check your answer. There's a fast way to go from this line right down to your IRC, which they call the first derivative. In calculus, you'll do it that quickly. Isn't that nice? That's why you do calculus, because you can do this and find the IRC in one line. But that will be another course. So there's your IRC, general equation. A couple questions to try. And we're getting ready toward the end of the unit, so you might want to start looking at some review questions as well. It's a short unit, but lots in it. And thanks.